Hello everyone. Today I'm going to talk about the topic called JDBC. Let's get into the topic. Introduction to JDBC. JDBC stands for Java Database Connectivity, a standard API connecting Java applications to databases. It provides a set of interfaces and classes to interact with various database management systems. JDBC enables developers to execute SQL statements and retrieve results from database seamlessly. Importance of JDBC. JDBC is crucial for Java applications that require persistent data storage and retrieval. It allows for the development of database driven applications that can operate across multiple database systems. The use of JDBC promotes the separation of application logic from database data management, enhancing maintainability. JDBC architecture. JDBC architecture consists of two layers, the JDBC API and the JDBC driver API. The JDBC API provides the application to JDBC manager connection, while the driver API handles the JDBC manager to database connection. This layered architecture allows for flexibility and compatibility with various database systems. JDBC drivers overview. JDBC drivers are essential components that enable Java applications to communicate with databases. There are four types of JDBC drivers. Type 1, JDBC ODBC bridge. Type 2, native API driver. Type 3, network protocol driver. And type 4, thin driver. Choosing the right driver is crucial for performance and compatibility with the target database. Type 1 driver JDBC ODBC bridge. The type 1 driver convert JDBC calls into ODBC calls, allowing access to ODBC compliant databases. This driver is discontinued in recent Java versions due to performance issues and dependency on ODBC. It's generally not recommended for production use in modern applications. Type 2 driver, native API driver. The type 2 driver converts JDBC calls into database specific native calls. It requires native library installation on the client side, which can complicate development. This driver offers better performance than type 1 but still has platform dependencies. Type 3 driver, network protocol driver. The type 3 driver uses a middleware server to convert JDBC calls into database requests. It allows for the use of multiple databases without requiring client-side installations. This driver is suitable for web applications where database independent architecture is desired. Type 4 driver, thin driver. The type 4 converts the type 4 driver converts JDBC calls directly into the database specific protocol. It is platform independent and does not require any native libraries on the client side. This is the most commonly used driver due to its simplicity and performance. Establishing a connection. Establishing a database connection in JDBC requires loading the driver and using the driver manager class. A connection is made using a JDBC URL that specifies the database type, host port, and database name. Proper execution handling is essential to manage connection errors effectively. Executing SQL statements. JDBC allows the execution of SQL statements through the statement prepared through the statement, prepared statement, and callable interfaces. Prepared statement is preferred for executing parameterized queries, enhancing security and performance. Callable statements is used for executing stored procedures with the databases. Processing result sets. Result set is the interface that provides access to the results returned by executing SQL queries. It allows iteration through the data fetching rows and columns as needed. Proper management of result set resources is crucial to avoid memory leaks. Transaction management. JDBC supports transaction management through the use of commit and rollback methods. Transactions ensure data integrity and consistency when multiple operations are performed. Auto commit mode can be disabled for batch processing, allowing for better control over transaction behavior. Error handling in JDBC. JDBC provides a robust mechanism for handling SQL exceptions using try-catch blocks. SQL exception is a primary exception class for reporting database access errors. Proper error handling improves application reliability and user experience. JDBC best practices: always close database connection statements and result sets free resources. Use prepared statement for dynamic queries to prevent SQL injection attacks. Utilize connection pooling to enhance performance and manage database connections efficiently. Connection pooling. Connection pooling reduces the overhead of opening and closing connections frequently. It maintains a pool of active connections that can be reused by different parts of the application. Popular libraries for connection pooling include Apache DBCP, Hikari CP, and C3PO. Using JDBC with frameworks, JDBC can be integrated with popular Java frameworks like Spring and Hibernate for enhanced functionality. These frameworks provide abstractions that simplify data interactions and improve productivity. They often include built-in transaction management and connection pooling features. Common JDBC operations. Common JDBC operations in JDBC include connecting to a database, executing queries, and processing results. Inserting, updating, and deleting records are fundamental CRUD operations performed via JDBC. Batch processing can be utilized to execute multiple queries efficiently. JDBC in a web application. JDBC is often used in web applications to interact with backend database for dynamic